Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 49, we will learn about activity-based modeling and how it is done in Cube. So, the different concepts that we will cover is activity-based travel demand modeling in Cube, and the different steps in the activity-based travel demand modeling, such as network cost, population synthesis, accessibility, then activity travel simulator, then travel aggregator, and finally traffic assignment. So, before I start this lecture, I will like to say that in module 12, we will cover activity based model in details. So, once you have done that particular lectures, there will be a series of 2 lectures on that. You can always come back and revisit this particular lecture, then it will probably give you a more better understanding of this particular better understanding of how activity based model could be conducted in Cube. But still, based on our previous discussions on activity based model, I think you would be able to grab the basic concepts, the initial concepts, and then of course you can again do this or go through this lecture once you have covered module 12. So, Cube Voyager, we have already seen how 4-stage model could be run in Cube Voyager, and as you know, Cube uses a flexible scripting language. So, it could be used to construct, modify those basic 4-stage models to include a tour based model, or we can also make it into an activity based model. So, activity based model, the concept we have already discussed earlier, where every individual has what kind of instead of modeling trips or even tours, we model what kind of activities are individual participates, and when is that an activity and where is that activity conducted, and how to support that particular activity. By example, how at what time it will start, what time it will end, then how to organize the activities throughout the day. These are the primary tasks, and the travel is a derived demand coming out of those particular activities. So, activity based model in Cube is loosely based on the concept introduced by John Bowman and Mark Bradley. So, there are several frameworks for activity based model. There are different variations of it, but the concept followed in Cube is a simple one, which considers the concept introduced by John Bowman and Mark Bradley. And this is an extension of the tour based model, and what is further included of we include the interaction and the constraints at person and household level. That means how different individuals within a household interact. That means do they share a ride, do they escort each other in a particular trip, like a father taking a kid to the school and then going to his office. So, this kind of interactions are possible. And then constraints are there. That means there are certain time constraints, there are certain destination constraints, and then there are certain like for example, if I go for a certain activity on a particular day, I cannot do something else. So, the number of intermediate stops that we will have in my tour depends on the time, and so many other things. So, these are the constraints that we are talking about. And then the spatial and temporal dimension of the activities, like where it happens, for how long it happens. So, at individual level, we create an activity day pattern choice, and before we do that, we also determine what kind of auto ownership the household has got, because that is one of the primary reasons that determines what kind of activities I can participate in, and that also determines my mode choice. And from here, activity pattern, we determine what kind of tours are generated and at what time of the day those are generated, and finally from there, once we determine the tours, we know what kind of mode and destination choice is possible. So, this is the framework for activity, this is the starting point for activity based model in Cube, and if you look into the broader framework, these are the different components involved. So, first job is to determine the total accessibility for a particular household. That means it could be, we have discussed accessibility earlier, where we have measured different forms of accessibility. It was done zone wise, but it could be also done individual wise. And then we have got a population synthesizer, like for micro simulation, we need to first synthesize the population. And this could be done both done using the Cube Voyager package. And then we have to determine the networks, we have to initialize the variables, and we have to once we have determined the network travel times, we need to do this we need to record these variables so that we can use them, and assignment of freight on urban network. So these are the basic data sets that we require, and this could be again created using CubeBase, QubeGIS, KubeCargo, and so on. And finally, this actually is loaded over, this is taken as input to this particular step, where we generate this activity or this activity travel simulator, which based on auto ownership determines what kind of activities would be generated, which includes both the kind of tours I will make, it includes the time of the day choices, it includes the mode choices, the destination choices, and so on. So then these are aggregated for different zones, which is done by travel aggregator. And finally, zone to zone aggregated travels by different modes at different times of the day is finally assigned to the network. And once we done that, once the assignment is done, we can generate reports, maps, and matrices which we can study. And this could be done by Cube Reports, QubeGIS, and Cube Analyst. And this part, activity travel simulator, could be done by CubeBase and Cube Voyager. So this is how the overall framework for doing or carrying out an activity based model in Cube. So just to show you the framework, so we have got we are using this a demonstration model in Cube, and we are using Cube's catalog. And from here we can open this from our activity based model, and you can see we can start with the network. This is input data, and then we have population synthesizer over here, and then we have got accessibility estimator over here, and then we have got a travel simulator over here. Then once the travels are simulated, we know that the time of the day, the tour patterns, then travel is aggregated, and once travel is aggregated, we can do travel assignment, and then we can generate reports and so on. So this is where we generate the reports. So as you know earlier, that these are the input data, these are the output data for each step, and these are the steps that are written. So this is accessibility, so this is travel simulator, this is travel aggregator. So each of them has got inputs in form of data sets or matrices, and then it has got outputs. So this is how this is an overview of the ABM model. So the first step is to initialize highway and PT costs. So as you know that before even we start any kind of modeling, like we require data on travel time between different zones or different stops, and like for transit it is between stops, for highway or the road network it is between zones. So centroid to centroid travel distances, travel cost, and so on. So that is first what we determine. So this is outside the feedback loop. So this is not within the iterative process. So first we estimate that, and it involves the calculation of initial scheme matrices for highway network and public transport network, and these are used for trip generation, trip distribution, as well as mode choice. And then finally when the iteration starts, then again those values would be updated, and we can have different iterations. At one point it will become, we will get stable results. So then generation, the next step is to generation of synthetic population. This step is outside the feedback loop, and this step creates a sample of individuals drawn from a table of survey records in such a manner to match aggregate zonal characteristics. Please you have to go back to the lectures on population synthesis, and which we have done earlier, and see all the steps have been detailed out there. So first what we do is we have cross classification data for different zones, and based on the sample data we actually can do different kinds of cross classification. We can segregate the population, and then we do iterative proportional fitting to match the zonal control totals along with the survey data, and finally we can draw random population from sample, and we can add that to our synthetic population till this zonal total matches. And so this process has been detailed out in our earlier lectures. So you can check those, and this is an inbuilt step in Cube Voyager, and using this we can also generate synthetic population for activity based models. So once we have done that, the next step is to determine accessibility. Again, accessibility could be done in different ways. So we determine accessibility for different kinds of trip purposes and for various times of the day and in both directions. So that means accessibility will vary depending on direction, which is understood because the zone changes, and it will vary as per the trip purposes and also for different times of the day. And we usually, in this particular case, a log sum measure is used, but you can always use your own measure. A log sum measure is a composite measure which includes the travel time by different modes in this particular case, and that actually gives us how accessible a particular zone is. So we have got different accessible measures, and these are all for walk trip purposes. So other purposes could be also considered in case of other kinds of trips. So this is the accessibility that is measured. And based on accessibility, and this is where you can see this accessibility is being measured. The input comes from the highway and the public transit schemes that you see over here. This is highway schemes and the public transit schemes and the zonal data which are being utilized to determine accessibility. And this is a step before the estimation of these highway schemes and transit schemes, and also a step before the activity travel simulator. So then is the main step, which is the activity travel simulator. This step generates activities and trips for synthetic population. So input is population synthesis, that population data that we generated, then accessibility and the network schemes. And so these are the two data sets that we actually use. And once these are the three kinds of data that we use, and then the first step is to create an auto ownership model. So these are based on again logit equations. We determine the number of autos in each household using their utilities, and then using Monte Carlo simulation based on these utility levels, we can determine which household to assign which number, how many number of autos that will own. So what we do is we use a Monte Carlo simulation where we pick a random number and we match the random number with the cumulative probability that we estimate using the utilities of those particular modes, and we see that in which group it belongs to, and that particular choice is assigned to this particular household, and accordingly so many number of vehicles are assigned to this particular household. So the input to this step is in synthetic population database and the accessibility tables that actually are the exploratory variables to determine the utility equation for mode choice, for auto ownership or vehicle ownership. So this is same as the vehicle ownership models that we have discussed earlier. So then comes the activity pattern choice. So this is again another set of utility equations where we choose the activity pattern. There are three main patterns. We choose the activity pattern for each person in the household. The pattern is either he is a worker, student, or a other adult. So either he goes to work, he goes to college, or somebody else. And we determine what kind of tours he does, what kind of tours and subtours he does, and what kind of tours, subtours, and intermediate stops he can do. So we can determine his tours. We can determine his tours and subtours, and the tours, subtours, and intermediate stop. So depending upon combination of all this that I will show in the next slide, we can have several options of tours that are generated for a particular individual and for a particular activity pattern. So again, for each of these patterns, we calculate utilities of these patterns based on, again, exploratory variables are functions of car ownership, accessibility, then household characteristics such as part-time worker, income level, having kids or not kids. So that actually gives different utilities for different patterns, activity patterns. And again, using Monte Carlo simulation, we can choose the pattern for that particular household. So this is, you can see for primary tour, these are the different, or for adult worker model for primary purpose 1. This is how many ways a tour pattern could be generated. He can just do a simple walk tour, or he can do a simple walk tour plus one secondary tour with a walk tour. Now, why this primary, secondary? For that, you have to again revisit this lecture once you have covered module 12. So, usually a person does a primary activity, then there are discretionary activities, secondary activities during an entire day. So, this is why these are being considered. So, he can also do like simple walk tour plus walk tour with intermediate stops and plus one secondary tour with a walk tour. So, these are the different combinations these are possible. So, these are the different alternatives, and each of these alternatives has got an utility, and the person chooses the one with the highest utility, and that gives him a probability, and using cumulative probabilities and Monte Carlo simulation we can actually determine what pattern will a particular person choose or what tour a particular person will choose. So, once we have done that, we need to store this data in 3 arrays. One array contains the primary tour, subtour or secondary tour purpose. The second array contains the stops before reaching the destination for each of these tours, or the third array contains stops after reaching the destination for primary tour. So, we are generating a tour, we have a destination, primary destination, and then there could be a secondary destination, and in between the journey we can also choose different stops. So, this choice of stops and all is actually modeled like which pattern he will choose or which tour he will choose is determined based on different utilities, of course based on observed data for different kinds of individuals. Each individual does different kinds of tours, and we can do that, and we need to store this data for further processing. So, over here you can see that then the next step is to do determine the time of the day. And over here you can see this is the activity travel simulator. The input comes from accessibility. Input to activity travel simulator is the highway schemes, the public transit schemes, the zonal data, the accessibility measures, and the synthetic population. And the output is trip records, tour records, and pattern records. So, all this is our output. So, this actually goes into the travel aggregator where we aggregate all these data sets. Anyway, that we will come to. And first, after determining the tours, we also need to determine at what time of the day the tour starts and ends. So, because it is both start and end, that means we can have different time periods. It could be like 4 time periods as in this particular example, like AM peak, midday, PM peak, off peak, or it could be even time periods of every 5 minutes or every 30 minutes. So, depending on that, a tour starts at a certain time and ends at a certain time. So, if I take both of them together, so it is a combination of start and end periods. So, that means for 4 time periods there would be 13 combinations. So, each of these combination has got a utility for this particular individual, and then again using Monte Carlo simulation we can choose the the start and end period, or rather that combination of start and end period for a particular tour for this particular individual. So, this is how the activity based travel model gradually proceeds. So, once we know the activity and the tours and all, the next step is to determine the joint mode and destination choice. And over here we first do the destination mode choice model, which is the subnest. So, based on the mode used by each person for each primary tour, subtour or secondary tour to reach a particular destination. So, this choice of mode is conditional of that what tour he is doing, of course, and then this is again done using Monte Carlo simulation and so on, and then we can determine the destination as choice as well. So, destination choice is determined for different kind of tours, subtours, secondary tours and so on, and here again we do Monte Carlo simulation, but we use zonal utilities and where composite utility of the different modes for each destination log sum so this is a nested choice model. So, first we have destination choice, we have mode choice. So, the log sum measure from the mode choice actually is used in the destination choice model. So, this is the conditional, and the mode choice is conditional upon that destination choice. So, this is how we do a joint destination mode choice model. Again, we have discussed this kind of models earlier, and for the utilities of each of these mode choice model, like for each individual and each tour pattern, utilities for different modes are basically different modes are considered, such as single occupancy vehicle, high occupancy vehicle, transit, walk, and the different explanatory variables are cost, or rather the utilities are measured using cost for tolls, fares, this parking cost, and then income level, tour purpose, in vehicle travel time, out of vehicle travel time, and so on. Then utilities of destination mode wise again could be determined based on cost for input scheme matrices for highway and public transit trips, parking cost, and other cost components based on car ownership, income level, and household size. So this destination choice model, mode choice models, these are similar to the ones we have discussed, and only thing we are determining a joint destination mode choice models, which we have also discussed this kind of nesting structures earlier. So once we have done that, we can next do an intermediate stop choice model, also following similar destination choice model, modeling processes. So this is how the total activity travel simulator works, and this is how we develop the base through which we determine the tours, the destinations, the time of the day, the mode choices. So once we have done that, the next step is to aggregate all this, which is done by an activity travel aggregator. So over here you can see that all the inputs are coming: trip records, synthetic population, AM trips, AM highway networks, and then this PM trips, and all the different time periods we will get this data. This is aggregated, and then we finally do traffic assignment based on what we have discussed earlier. We divide as per different car occupancies, we divide the data as per the different time periods, and then we do hourly assignment to the network, and we finally get a traffic loads throughout throughput throughout the network for the AM period. So that we can see over here. So similarly, we will have for PM period and so on. So this is how the activity based travel demand modeling could also be done using the Cube software. So these are some of the references you can use. And to conclude, Cube Base, Voyager, and Cube GIS can be used to create an activity based travel demand model. Cube Script can be used for modeling, customizing the different steps, and to include new options. Different scenarios can be developed under the scenario panel, and the impact of different policies can be assessed. And this model gives suitable input for emission modeling software to estimate emission caused by different modes across different times of the day. Thank you.